Welcome back to 3D from Nothing, powered by Metalmite, the show where you learn all about 3D printing and additive technology. I'm your host, Tom Gendich. Metalmite's a full-service machine shop. We specialize in 5 and 6 axis CNC machining, CNC grinding, wire EDM, and 3D printing. We're a 50-plus-year-old company that was started by my father, Michael Gendich III. I took over by a CEO in 2009, and I'm continuing the manufacturing legacy today. These programs, we're going to learn all about what kinds of printers are out there, what kind of material you can use, who are using these printers, and what kinds of things you should be looking to print, as well as hearing from experts in the field and conducting surveys and interviews on the best 3D printers to market. Today, we have a wonderful show planned. I have a special guest here, Paul Hollowaty, which some of you might have seen familiar as we interviewed him a year or so ago. Paul is now with Velo3D. Welcome to the show, Paul.
Thanks, Tom. Great to be here.
Absolutely. As a quick recap for those who don't know, you've spent the better part of the last 20 years in additive technology?
Yep. I started selling 3D printers back in 2005. Moved around a little bit and spent the last 10, 12 years on the metal side in various forms of metal AM. From cold spray to laser powder bed fusion to electron beam melting.
Gotcha. So you've got a pretty good handle on the industry as a whole, seeing all the different technologies and obviously the different manufacturers. If memory serves me correct, I think you were the #1 salesman for Stratasys for a while. Didn't you hold that title?
Yes, in 2009. So that was pretty exciting. It was a fun time to be in selling 3D printers.
And newer to the market, lots of people getting into it at that point. And
yeah, I could open up my sample case, and in some cases I would get a PO right on the spot. So it was exciting.
Nice, blowing minds. And I think you continue to be in the middle of where the action is. On one of the last shows, I covered Velo3D and where they've been in the market in the last 3 years. And I think since my last show, they've now gone public. I think your founder CEO was seen ringing the bell there on Wall Street as they went public. It was just the end of last year, wasn't it? End of 2021?
Yeah, it was September 30th that we went public.
Fantastic. Really, a really short time period from the inception. It was founded in 2018, I think it said, or?
No. Benny founded the company in 2014. We sold our first machine in 2018.
Okay.
So it's a relatively new company to Metal AM. And I think some of the benefits are that we've learned a lot of mistakes that previous companies had made. One of them being we're powder agnostic. Another one being we don't build parts. We're not in competition with our own customer base. So that's why we have a strong and thriving contract manufacturing network. And we've actually got a team of engineers that are looking for those compelling, complex, high-value metal parts that would be suitable for our equipment that we steer towards our contract manufacturers. So with a strong...
Go ahead. I was going to say, it was one of the things I was able to listen to Benny on a podcast recently, and he really stressed, I guess in his career, he spent a little bit of time as a venture capitalist looking to fund some 3D printing companies. And he became, I think his words was, I can't remember how he phrased it, but he was against the fact that there was so many variables on the market. You take an EOS machine or a 3D Systems machine and you sell 1,000 of them to 1,000 different customers. He said you could literally get 1,000 variations of the same part by sending it to those customers. So he was quoted infamously, I guess, at this point, as saying he would never invest any money into 3D printing. And it sounds like he has to defend that now. But he said he still believes what he said because he didn't like the way the market was going, in that an end customer like Boeing or SpaceX or Rocketdyne or whatever could not trust that the part coming from that machine was going to be the same. And tell us a little bit about, it sounds like Velo started a little bit on the opposite end of where maybe EOS and some of those other guys started, where you guys started with the software and you wanted to make sure you had integrity across all platforms. And if Boeing ordered one part, then turned around and ordered 1,000 more, you guys can promise that part's going to be the same when it arrives to them.
Sure. Yeah. Benny started the company in 2014. And the reason he started it, he was a physicist working for a venture capital company. So he was doing the due diligence on some of the companies that were investing in. And he was working with a rocket company who came to him and said, hey, we've got these great designs, but we can't build them on our current systems. So he got some funding and he started his own company. And he with the original intent of becoming a contract manufacturer to produce these impossible parts. So he purchased the conventional metal AM system, used the conventional third-party slicer, and quickly realized that it wasn't going to be possible with the equipment that existed today. So as a result, he built the first Sapphire. And in order to make these parts, he had to build the software too, the slicer. Now, what's unique about our slicer is that we're taking in native CAD files, and our software recognizes the geometry of the different features of the geometry and applies recipes to that part. The printer, we've got over 900 sensors on the printer, and it executes those instructions. And then on the back end, we have Assure, which is our quality validation software that monitors the tool health and the actual printing of the part. So it's a true end-to-end solution, and our we're always looking for those compelling parts, those complex, high-value metal parts where they can't be defamed or there can't be any quality compromise. That's where we play. And
I got a question about that. Are you
Yeah.
guys the only one taking that much control in the slicer and the print side and the quality side, or are other people starting to come along now realizing that that's a necessity?
Yeah, to my knowledge, we're the only ones, and
Wow.
I know all the other competitors, but several of our customers said that we're 5 generations ahead, and it's really exciting. And I would invite you to come out and visit our R&D center and our manufacturing plant out in Campbell, California, out in Silicon Valley. It's always great to bring customers in because in our R&D center, we've got our original 6 Sapphires there, and they're R&D machines. We're working on new materials, new processes. So they've got the panels pulled off, and then we've got the Alpha Sapphire XC as well as the Beta Sapphire XC in our R&D lab. And so you really get to take a look under the hood of our equipment and see really what we're doing. Yeah, it's exciting.
Now, one of the things, again, I overheard Benny talking about on his interview, which was, I think it was just a week or two ago, so it's pretty recent. It was made pretty public that a certain eccentric billionaire or trillionaire who owns a rocket company approached him and tried to buy Velo for himself. And Benny said in the interview, it was difficult to resist because it was a lot of money, but he told that eccentric billionaire that he would continue to offer a great product and serve his company, but that he needed to maintain the independence of the company in order to, he was really trying to change the industry, and he really wanted to make sure that the industry as a whole benefited from what he was trying to do with the software and the sensors. You talked about the 900 sensors and calibrating in between each layer, and several things that were important to Benny that he didn't see other manufacturers doing. And so I found that really intriguing, that from his own pocketbook standpoint, he could have maybe done better by just selling the company before going public. But from the sense that he was really a person on a mission to change an industry, it really says a lot about Velo from the top down on how they want to make it happen. So, what, you have any thoughts on that?
Yeah, it's well, that particular customer is currently one of our largest. We've got other customers that are approaching that, and they're a great partner. But Velo, I've been with Velo for 9 months, and it's an absolutely remarkable company. From the design and development. And again, we're designing and building. We're the only laser powder bed fusion company in the world manufacturing our machines in the US. And a third of our employees came from the semiconductor industry, which really gives you an idea of how the level of detail we're taking in designing and building this equipment. But what struck me when I first started with Velo is the customer support. We have weekly meetings with every single customer, and we discuss half-hour meetings. We discuss what went right, what went wrong, what does their backlog look like? Do they need any help with anything, with any file preparation, any spare parts? And we have a 2.5 to 1 ratio of machines to field service technicians. So we are able to, if anything goes wrong on the equipment, we're able to get to the customer within sometimes hours, but at the latest 24 hours.
2.5 to 1. You have 2.5 machines to every 1 service technician?
Correct.
Wow. That's incredible.
Yeah.
That's well supported.
The service is unlike anything I've ever seen. And the innovation, we've been told that we're 5 generations ahead, and that's the goal, is to maintain that gap.
And it's interesting because from a technical side, and I'm not the one at the controls printing these parts, but as we covered with you last time you were here, we do have 7 3D printers in-house, and we also make some parts for the same market that you're talking about. And in the printing of Inconel specifically, we've been finding we're struggling a lot with warpage. We're printing on a plate, and we're making a fairly thick part for a rocket engine. The warpage values that our manufacturer has told us haven't been real accurate. So we've had some issues that we've been dealing with, and the manufacturer's been pretty good with us getting involved with solving that problem. But one of the things, you recently got a chance to meet with my top 2 additive guys, Greg and Bill. And one of the things they said after meeting with you is that your machine, both of them that you demoed, calibrate after every single move. And the whole idea of warpage and movement and the coefficient, it sounds like Velo has really figured out the science behind that to make sure that movement is accounted for and that you end up with a good part at the end.
Yeah, that's one of the keys to what we're doing is you can do a full calibration on the machine. It's a push button calibration prior to every build if you want. What we found is that once a week is generally acceptable. And that's what most of our customers do. So the quality assurance software will tell you when the machine needs to be calibrated, when the filter needs to be changed, the health of the machine. It's pretty amazing. And what we're able to do is to build parts without compromise. So with Metal AM, as you're familiar with, when you create supports for a part, they're really anchors to hold the part down. We're basically micro welding every 50 microns. So if you have a thin overhang, what it wants to do is lift up if it's unsupported with conventional metal AM. With our advanced processes, we're able to build 0-degree overhangs without supports. Now, we're not completely support free, but we're support free where it's important. For instance, a shrouded impeller, you wouldn't be able to remove the internal supports. Now, there's ways that conventional metal AM can get around it by propping it up on a 45-degree angle, but then your build time is much longer. You're spending a lot of time and money on supports, and you lose your concentricity. So you'll never be able to balance it when it's spinning at 30,000 RPM. So that's really what's key, is we're providing engineers with the design freedom to build the parts they want without a compromise.
Yeah. And like I said, it sounds like from a scalability standpoint, I understand that you alluded in the beginning of the conversation about developing, what did you call it, a contract network?
Yeah.
So it sounds like from a scalability standpoint, again, a customer asks you to develop a rocket part, an impeller, or whatever, and you finally nail it and figure it out, you would have the ability to get him a scalable production lot size of that pretty quick, because every one of your contract suppliers would print it the exact same way with the exact same material. Is that what I understand?
Yeah, our systems are production systems. So we have a closed loop powder handling system, before I answer your question. And to change out materials on a metal 3D printer and to print parts for aerospace or space customers, they won't accept those parts because there's risk of contamination. So when you buy a Velo Sapphire Inconel 718 machine, that's what it's going to be used for. Generally, when our customers need a new material, they'll buy another machine. It is possible to change out materials, but it's not recommended depending, on what industries you're working in. So what we have is a Velo print file, and it's very simple for us because we're using native CAD files. So we go from the CAD file into our flow software, which creates a Velo build file, and we orientate the part, we apply whatever supports are required, and the software automatically applies any other recipes. And we even have the ability to veer from that if there's any special requirements. So we've got a number of sub recipes. And these are recipes that we've developed over the years that are continuing to grow because our engineers are always looking for that impossible part. And when we find a part we can't build, we'll figure out a way to build it. So after you orientate the part, apply the recipes and supports, you slice it, and then you've got your locked in Velo print file. Now that's a non-editable file, and that's what large OEMs can send out to the contract manufacturing network for quoting. And as long as the machine is using the same material and it's in calibration within that week calibration, 1 week calibration, they're getting the same exact parts, whether it's today, next year, or 20 years from now. Now that's what really developed our contract manufacturing network. Is with conventional metal AM, big companies, space companies like SpaceX were not able to outsource metal AM parts. It wasn't until Velo came along with our end-to-end solution that they were. Now it's a regular basis. And as many machines as they have, they still outsource a lot of work. So
yeah, I think in the industry, to hit your point, some of those super large OEMs like was it GE engine? Didn't they buy a complete manufacturer of some sort to try to solve that problem? They wanted to have the same machines and they wanted to own them in house and all that. And I forget which company they bought, but
they bought Concept Laser and
yeah. But from what I read or what I understood, that was a problem that they were having. They had 2 or 3 of the early suppliers, and they couldn't get parts to repeat. They couldn't get the same part twice. And as you said, in aerospace, especially engine manufacturing, they needed it. So their solution at the time was, let's buy an entire company and then make sure every part's the same. But I don't know if they actually achieved that with what they were trying.
One of the other issues with conventional metal AM is that you're starting with a CAD file, going to STL, then you bring it into a third-party slicer, and then you bring it into your machine to execute those commands. Now, what happens with some, not all, but some metal 3D printers is that each time they calibrate the machine, they have to change that part file. So on conventional metal AM systems, they're bringing in a field service tech to calibrate the machines on a quarterly basis with using external hardware to do that. So you could have 4 different print files in a 12-month period. And what complicates that is on a conventional metal AM system, if I build a part today, that's one thing, it qualifies and blah, blah, blah. But if I build it a year from now, I have to make sure that I use the most updated file. So it becomes very complicated, and we've really simplified that whole situation.
Talk to me for a minute about, you talked about your engineering team. Talk to me about the different materials. I saw recently you guys have added copper that I believe NASA asked you to develop that specifically for one of their applications. How many materials are you up to, and how does that process work where you add new materials?
It's based on customer demand. We started with Inconel 718. Right now, we've got 9 materials that are production ready material processes. We've got at least 6 coming soon. And again, they're based on customer demand. So we've got Inconel 718, 625, Ti 64, aluminum F357, Hestaloy X, Hestaloy C22, Scalmalloy, Haynes 282, and copper GR Cop 42.
Now, a lot of those that you just named, especially the titanium and aluminum, those are the historically they've had the trouble, right, with the starting fires and the reactivity of those being laser sintered. How have you guys, if that's a simple answer, how have you been able to make it safer to sinter those?
Our machines, we have 2 machines. It's the same machine, but we have 2 versions. One is reactive and one is non-reactive. And the reactive machines, remember that we still have a closed loop powder handling system. So once you put the powder in, it does not see oxygen until you remove the part.
Is it in a vacuum then? Is it vacuum sealed or?
Yes, we have a
Gotcha.
unique recoder. Maybe I should touch on that real quick. The standard recoders will the piston holding your build plate will come down, and then recoder will push powder across the build plate and then back. So with our systems, we're actually using a non-contact recoder, which is very unique. It's a protrusion tolerant recoder where the recoder comes from back to front, lays down about 3 millimeters of material, followed by a normalizing blade, and then we vacuum up the remaining powder to precisely 50 microns. And then it goes back into the garage, and then as we're lasing, it's creating smoke and soot, and we've got a nice clear path for the argon to flow across.
Okay. So you've really tackled all variables of that issue, because I know some of the buildup and
that's the problem when you're working with very low angle thin parts. Your parts will tend to move, and recoder crashes is a big problem with conventional metal AM. So we've got a tolerance of 400 microns, and then the operator will get a text and a warning. And then we can go up to really 700 microns, 800 microns before there's danger of the part hitting the recoder, and it automatically stop at that point. So it's everything from the Assure quality software, where we take photos before and after each recoat, as well as structured light scans.
Oh, wow.
And we're measuring everything on the system. Now, at the end of a typical build, we're at about 1 terabyte of data, but we consolidate it down into a single build report that will give you the tool health quality, as well as the serial number and the part information.
Interesting.
And that build report can be sent to the customer, which a lot of our customers require it from the contract manufacturers, and can also be filed away with the particular build.
Gotcha.
So that,
In your list of materials as well, you mentioned aluminum. I know that's been a massive request in industry, is a good solution for additive on aluminum. So which aluminum did you get approved at Velo?
It's called F357. It's it's an excellent material that's very similar to a casting material. It's aluminum casting material.
Okay.
We decided not to go with the common ALSI 10 MG, and thought there was more value in F357.
Okay. And same thing there. So someone that would typically order a casting, you can print a few to prove a concept, and then you have the scale of your contract network to be able to give the OEM volume pretty quick.
Correct.
That's amazing. I love that concept.
Yeah, it is pretty amazing. We started in really space, and we're in every single space company that exists. We do a lot of work in aviation, energy, defense, And being in the Midwest, I don't have space companies on every corner like they do in Los Angeles. So I'm constantly looking for new applications that use that same idea of optimizing fluid flow or exchanging heat. And what I've found is some applications in the high pressure die cast industry, which is basically doing exactly what we do, what our goal is. And it's pretty amazing because they're looking at very large tools. And the larger tool they get, the larger cooling channel they'll need. Conventional metal AM can typically build cooling channels up to 6 millimeters, and then the downskin surface will become very rough, and that's where the cracks will propagate from. So we're able to build the first shot we had at it, we built from 2 millimeters up to 15 millimeters, and we're very successful with it. And the customer commented that was better than he had done in 7 years of working with a conventional system.
Really?
Yeah.
Wow.
So that's our way into the automotive industry. And automotive really hasn't been a good industry for metal laser powder bed fusion because their volumes are so high. So you really have to look at tooling applications.
That's excellent. So it sounds like there's a constant hunger within the company to find new applications, and as Benny said in the other interview, he really wants to change an industry, not just offer another product on the market. Fantastic. I do want to be sensitive to the time here. I know we had a hard stop here, but as we wrap up, I know you have you're on tour this next month or two, right? Aren't you? Isn't Velo going city to city, offering some sort of view at your two machines?
Yeah, we have a road show that we just did one last month in Detroit. We're going to do about 13 this year. We did one in Pittsburgh a couple weeks ago. We've got one in Boston. I think it's next week. And then we go out, and then we've got a couple in Europe. We've got one in Fremont next month, and actually Fremont is this month. And then we've got one in St. Louis in June. So it's a great opportunity. It's usually from 9 to like 2. We'll have it at a nice facility. We'll provide lunch, and we'll have about 3 or 4 speakers, engineers, give their presentations and really give people an idea of what we're doing and what we've already done. I know for myself, before I started with Velo, I had a lot of questions. How do they do this? How does that non-contact recorder work? How are they printing 0-degree overhangs? And all of our technologies are patented. So we're fairly open with what we're doing, and we'll show you what we're doing and why we're doing it. One thing I do want to touch on before we quit is we've got our Sapphire, which is our first machine. It's 315 millimeters in diameter by 400 millimeters tall with 2 1-kilowatt lasers, where our inert environment is argon and our standard layer thickness is 50 micron. In situ monitoring, we've got 970 sensors on the machine. Now we've also got an identical machine where we extended the elevator and we can go up to 1 meter in the Z. But our newest machine, which we're all very excited about, we shipped our first Sapphire XC for extra capacity in December. And we actually just shipped a machine last week to, I probably shouldn't say, but we shipped several machines so far. They had a reservation on those machines, and we've got about a 40 machine backlog.
Wow.
But what's significant about those machines is they're huge. With 600 millimeters in diameter by 550 millimeters tall. And we're using 8 1-kilowatt lasers.
8 lasers. Wow.
8 lasers. And so you can build large parts or you can build a lot of small parts. And it's really changing the cost structure of metal AM.
Yeah. Yeah, it sounds like it. As Benny said, he wanted to set out to change an industry. It sounds like he's doing it. So there's gonna be a lot of people trying to catch up at this point. And then also, are you able to talk a little bit about the joining the contract network? What if some shops like myself or others want to be part of that network? Is there still opportunity to do that?
Yeah, it's not like a private membership. You buy a machine and we will diligently work to fill that machine with you.
Okay.
What's interesting, as we add new OEM space companies or defense institutions, they'll have a need, and there's only so much capacity they have, and they'll have a need to outsource parts. And typically what we do is we'll take a look at the part, verify that, hey, yes, it can be printed, and then we'll introduce them to one of our contract manufacturers.
So I think that's a little different than most. As I said, I bought several machines at this point in my life, and none of the OEMs have connected me with a customer. So that's a little different on the Velo relationship as well.
It really is. And Benny really believes in building up that strong contract manufacturing network. That's what's really going to grow the business, because you have to have a strong company to buy multiple machines and use them successfully. And that's what promotes the technology. And I would love for you guys to get a machine. I know you're moving into a new building, but I think we've got a lot of common customers, and I think you'd be successful right off the bat, especially with your previous experience.
We're definitely chomping at the bit. We've been big Velo fans for a couple of years now. And I think, like I said, Greg and Bill from Metalmite already connected with you and got a quick demo. I know they're looking forward to seeing some more here in the next week or two. Hopefully that can be added to our repertoire pretty soon.
We will have a booth at Rapid. So if anybody's interested, please stop by our booth at booth number 1508.
Okay. That's perfect. I was gonna end the show with saying, if anyone listening to this wants to get a hold of you personally for more questions, what's the best way?
The best way, I've got my contact information on LinkedIn, but my email address is paul.hollowaty@velo3d.com.
I'll make sure that's in the show notes and on YouTube so people can find it. But Paul, I really appreciate you taking time out today. We appreciate your professionalism, and like I say, your vast, almost 2 decades now being an additive has been fantastic. I really value you as a resource in this industry, and hopefully I get a chance to work with you here with Velo. If we can be a Velo part of the contract network, would be excellent.
That would be great. And we'd like to have you. I think you would be one of the first contract manufacturers in Michigan. So I think that would say a lot.
As my shirt, my son just graduated last Saturday from the University of Michigan. So we'd be honored to represent Michigan as one of the first Velo contract houses.
Great. I hope it happens.
Paul, thanks for your time today. Appreciate it.
Thanks, Tom.